Here's the last group of VSEPR shapes. They're all based on 6 groups of electrons on the central atom. The base, the one that we want to compare all the rest to, is called the octahedron. So in a true octahedron, you've got 6 bonding regions around the central atom. So something like sulfur hexafluoride, where sulfur is taking an extended octet to carry 6 bonds. You have to visualize this octahedron. Here's how those 6 bonds are organized. 4 around the center in a perfect square. These are 90-degree angles. Then you've got 1 up on top, 1 atom on bottom. It's called an octahedron because there would be 8 faces to this 3-dimensional structure. It's all 90-degree angles, 90 around the square, and then it's also 90 from the central square down to the bottom or the top. So it's all 90-degree angles throughout the entire structure. Well, that's kind of nice, huh? So I have to visualize in my head this octahedron. Square around the center, that's 4 atoms. 5 and 6 go top and bottom. So 5 and 6 are like 180 degrees apart. When I look at a square pyramid, I still have 6 regions of negative electrons. 1, 2, 3, 4, 5 bonding regions, and 1 lone pair. These are some kind of crazy Lewis structures, huh? Check your electron count. If you don't check the electron count, you're not going to get that extra lone pair on bromine, and then you're not going to get the right shape. So bromine can take an extended octet, which obviously he has already with the 5-fluorine. So the only way you know that there's supposed to be a lone pair on bromine is by checking the electron count. So there's really 6 regions of electrons on bromine. Okay, so that makes me think in my head the octahedron, but I have to remove one of those spots to represent the lone pair. Make yourself a little note. With the sixers, the shapes based on the octahedron, remove atoms, top and bottom. This is a little different than the last video when we were looking at the fivers, the structures based on 5 regions around the center, or that Trigonal Bipyramid. With the Trigonal Bipyramid, you end up with the most stable structure if you remove from that central triangle first. Visually, like in your mind, think about removing from the top and bottom. I mean, realistically, no matter how you spin this thing, you got 90-degree angles. But if you're trying to visualize the shape, think about removing either the top atom or the bottom atom. And then the name kind of makes more sense. It's called a square pyramid. Do you kind of see it? If I remove like this bottom atom, and it could obviously be the top atom too, you still have a square around the center. So 90 degrees. And then you only have 1 atom like kind of up on top. So do you kind of see how this is called a square pyramid? So I think if you visualize that in your head, like first think about the octahedron, and then if you have a lone pair, visualize yourself like removing from either the top or the bottom. I mean, technically it could be any, they're all 90-degree angles, but now the name of the shape makes more sense visually. A square pyramid. It's still a square around the center, but it's a pyramid because you still have that 1 atom up on top. So again, then that's going to make this last shape make sense in your mind too. Check your Lewis structure. Again, be real careful because you got octets on the chlorine. You got an octet on the iodine, the only way you know that iodine is supposed to have an extended octet is by counting the total electrons. You should have a structure with 36 total electrons. So any electrons that are extra go on the central atom. Again, I understand like chlorine could take an extended octet too, but the most stable structure will always have extra electrons on the central atom. So I got my Lewis structure. There are 6 groups of electrons. There's 1, 2, 3, 4 bonding regions. And then there's also the 2 lone pairs, the 2 non-bonding. So in your mind, visualize yourself removing from the octahedron top and bottom. Because now this shape square planar makes total sense. If in your head you visualize that you removed the top atom and the bottom atom, and you replaced them with lone pairs, look what you're left with. Just the square. 90-degree angles. And so that's why it's called a square planar. It's just a flat square. I should mark in too, even in this square pyramid, these are all 90-degree angles, no matter how you look at it. It's 90 degrees around the square, and then it's still going to be like 90 degrees from the top atom to the square. They're all 90 degrees. So you don't have to think about any funky angles, but I think the shape makes more sense if you visualize yourself removing the atoms top and bottom first. Otherwise, you got all these shapes, and a lot of times I hear people that'll just say, like, I don't want to memorize all this. I'm so bad at memorizing all these names of shapes. You can't memorize them. You really have to visualize them. So if you draw the Lewis structure and you have 6 regions around the center, whether it's bonding electron regions or lone pairs, picture this guy. Picture the octahedron. And then if you have lone pairs, picture yourself removing atoms from the top and bottom. And then these shapes kind of make sense. The square pyramid or the square planar. If you had 5 regions around the center, visualize this. The Trigonal Bipyramid. 3 in the center, that's your triangle. And then bipyramid, pyramid on the top, pyramid on the bottom. Now if you have lone pairs, visualize those lone pairs going around the central atom first. Going into this central triangle. So if you remove 1 atom, it's like the seesaw. 2, you're kind of left with that T shape. Or all 3, what you're left with is linear. If you have 4 regions around the center, you in your mind really need to picture this tetrahedron with 109.5 degree angles. Because then if you have one of those spots that's maybe not really an atom, it's a lone pair, Trigonal Pyramid makes sense. You've got 3 atoms, that's the trigonal part, but it's not flat. It's a raised triangle. If you have 2 lone pairs, again, it's not linear, it's bent. What you're left with is still bent. And I guess kind of similar, the trigonal planar and this bent go together as well. Trigonal planar, 3 atoms, no lone pairs, 120 degree angles. Now here if you have 3 electron regions but one of them is a lone pair, again what you're left with is bent, but the angles are a little bit bigger, slightly less than 120, a little bit larger than this bent, where they're slightly less than 109.5. So if you get good at visualizing like the anchor structure, the trigonal planar, the tetrahedron, visualize the trigonal bipyramid and the octahedron, then hopefully the rest kind of start to make sense to you. But it does take a little practice, and you have to get the Lewis structure right, which could potentially be like the hardest part of the whole thing.